Hello, and welcome to Science 9 in about 10 minutes, plus or minus. We'll see how we go. Starting with static electricity. Hopefully you guys will remember how an object can have either a negative charge here, or a positive charge, like in this one. And that when two objects of different charges come closer to each other or in contact with each other, they experience a force that pushes them away. Whereas if you have two objects that have the same charge, they will push away. And I'm pretty sure just a second ago I said these ones will push away, but what I actually meant to say was that they will attract each other. See how the arrow was very good. I didn't get the rest of it. So those two charges, positive, negative, and then we also have neutral charges, which is what most, or I should say, all objects tend to go to, is neutral. In other words, as long as there is a way to get rid of extra charge, they will become neutral. And they are also attracted to anything that's positive or negatively charged. If you think about lightning, think about cloud, and then ground, or the earth. What lightning really is it's a buildup of charge in the clouds from rubbing against each other and other things in the atmosphere, and the atmosphere itself, it becomes charged. And then that charge suddenly jumps from one thing to the other. And it actually goes up the lightning bolt to the positively charged cloud. Why does it go up the lightning bolt? Well, because what electricity really is it's electrons that are moving between atoms. So the positive charged protons can't move down, but the negatively charged electrons can move up and create a neutrally charged system. This is pretty much how electricity works. You've got your battery, and one side of it is negatively charged, the other side of it is positively charged, and that charge goes through your circuit back up to the top, back up to the positively charged side of the battery. And that's really all it is it's just a negative charge moving back up to the positive charge. And the direction that it's going in the end won't matter, but we always look at it as going from negative to positive. So let's talk about amps. Amps, or amperes. Ampere is a long name. Amps is like an abbreviation. An amp is like the volume of electricity. So like liters per second, but it's really electrons per second. Electrons per second. This is a bit of a simplification because amps is really coulombs per second, but a coulomb is just a really large number of electrons. So electrons per second is basically what we're looking at. It's the speed that the electricity is moving in. Volts. Hopefully you remember what they are. You might remember the definition potential difference. PIA difference. And that is really not very helpful to a lot of people, including me, because it means nothing. Another way to think about it, about volts, is the amount of energy, so like in joules, per electron. per electron. What that really means is that for every electron that's going through the circuit, for every electron, it has some energy, or some ability to do something. For instance, that energy could be used to turn a motor, or it could be used to turn on a light bulb. But that's what volts is the amount of energy, the amount of ability to turn that motor, or the amount of light that light bulb will create, that's in every electron. The other important thing that you guys should know about is resistance. And you put that over here. Resistance. Every circuit has resistance, even if it doesn't have like a resistor, like the actual component. Even the wires that are conducting the electricity will be somewhat of a resistor. The resistor resistance, I think it's pretty self-explanatory. It restricts the flow. It restricts the flow of the electricity. Of electricity. The electricity. There we go. And there's a mathematical expression you can use to calculate volts, amps, and resistance. It's called Ohm's law, because the guy who made it was named Ohm. And I should mention resistance is measured in ohms. Ohms. So Ohm's law states, Ohm law, that's such an awesome word. Something's wrong with my spelling today. Ohm's law. It states that volts, where's my pen? I want my red pen. Volts equals amps times R. It also states that volts divided by amps equals R, or that volts divided by R equals amps. These are all really just the same thing, written in different ways with algebra. There was a triangle that some people find really helpful to remember Ohm's law. And it looked like this, and it had volts, amps, and resistance in here. And basically, it's just what I've written right here in red, but in a triangle form. So if you divide volts by amps, you'll get resistance, and if you multiply amps by resistance, you get volts, etc., etc., etc. And that's the same for the overall voltage, amperage, and resistance for any circuit. That's the whole thing. But what if we want to look at just a little bit? Well, I'm out of time, I think, so I'm going to have to look at that in the next video, where we're going to talk about series circuits and parallel circuits, which are pretty simple to understand, but as far as I've been able to tell, really hard to explain. So I'll do my best.